Hi, this is Lakshmi Kantiwari. In this lesson, I am going to teach you about a feature selection of filtering methods with the correlation coefficients. So basically in this lesson, what we are going to do, we are going to remove all the features which are correlated by a certain the coefficient by a certain point. Okay. So we will be talking about the correlation. What is the how we can remove correlated features, and then I'll show you how you can calculate the correlation and basically the correlation coefficients, and then we will remove all the features which are correlated with more than 0.85. That means if the correlation coefficients is more than the 0.85 or less than minus 0.85, in that case the features are very highly correlated and those features might not give extra informations to do a final prediction. So we will remove those features, and by doing that ultimately it will improve our models, and it will take less time to train our model. And then we will start by calculating the correlation matrix. But before that, I must tell you that if you are just watching this video, then what you need to do, you need to go ahead, you need to go previously and watch my previous video in which I have taught about the feature selection with the filtering methods, where I had removed constant, quasi-constant and duplicate features. Since this lesson is I have started from the from where I had ended this lesson. That's mean all the files are processed, and this file is available in the video descriptions from where you can download. So we'll be working on the Santander dataset. In the previous video, I had removed constant features, and then I had removed quasi-constants, and then I had removed also duplicate features. And then we had got here training and the testing dataset, which is xtrain and xtest unique. And on this lesson we will be working on the xtrain unique and the xtest unique. That means if you want to get this data, then you need to watch previous video. Otherwise you can download this file and you can run the previous cells, then you will reach till here. Okay, perfect. So after that, after calculating the correlation matrix, then we will get all the features which are correlated with more than 0.85, and then I'll calculate, and then I'll remove all the features which are correlated, and then I'll calculate the performance of the models, the random forest models, along with the time as well as the accuracy. And after that I'll also I'll do a grouping of the correlated features. So here you see, I'll show you the grouping of the features. Yeah, so here you see, so these are the group of features which are highly correlated with each other, and once we calculate these grouping of the features, then we will select a single features from each of these group by doing a feature importance based on tree based classifiers. And the tree based classifiers, that means the random forest classifiers we will be using, although you can use decision tree as well or any other tree based classifiers. Then after that I'll be doing getting the most important features from each group, and then I'll show you how you can calculate, how you can do a performance comparison between the original data sets and the uncorrelated data sets without the grouping, and uncorrelated data sets with the grouping. Here this is the without grouping and this is with grouping. So this will be the all in this lesson. So without wasting a time, let's go ahead and start this brand new lesson. But please don't forget, you need to watch a previous video, otherwise you can just download this file and run this till my previous videos. Okay, so let's go ahead and start a new lesson. So our data set generally contains correlated features as well. So the two or more than two features are correlated if they are close to each other in the linear space. And our main goal is to remove correlated features to reduce the dimensionality of the overall feature space. As with this figure, it is very clear that if we increase the dimensionality of our features, after a certain point, the overall performance of a machine learning model start decreasing, and the total training time of our model start increasing. So as we increase the number of features or a dimension of our feature, first initially our model's performance increases, but after the certain points, which is also known as optimal number of feature points or a sweet spot, after this our machine learning model performance start decreasing. So it is always recommended and desirable that we should choose an optimal number of features. So previously, as I have speak about that, I have already spoken about that. Constant, quasi-constant and duplicate feature removal. In this lesson, I'll show you how you can remove a correlated features. If your dataset has a perfectly positive or negative the correlation, then there is very high chance that the performance of your model will be impacted by a problem called multi-collinearity. The multi-collinearity means if two or more than two features are correlated with each other. Moreover, you can say that the multi-collinearity happens when one predictor variable, that's mean the feature variable, in a multiple regression model can be linearly predicted from other with a high degree of accuracy. That's mean, for example, let's say we have the two features and then one output. Okay, for example, if first feature can be predicted by second feature and the second can be predicted by the first feature in linearly, then there is no information gain while predicting the output. So it is desirable to remove on any one of these two the correlated feature, for example. Okay, in the same way if there are so many features are correlated, then we can remove. So there are certain machine learning models which are impacted with these collinearity. But in general, the decision tree algorithms have immunity to the multi-collinearity, but they doesn't have a full immunity. So it's always recommended to remove the collinear features. So the correlation between the output observations and the input features is very important. Okay, so this is not always the collinearity between the feature space and the output is desirable, but the collinearity amongst the feature space is not desirable. Okay, so we need to remove that collinearity. So here if you see and we will remove that collinearity by computing the Pearson correlation coefficients. So if your Pearson correlation coefficients are high, that means those features are pretty much collinear with each other. So the mostly we will select if feature space is the not correlated by more than 85%. That's mean if correlation factor is more than 0.85, then we will filter out those features. We will not consider while training our model. So here is Pearson correlation coefficients, how we calculate this formula. So basically you can say that this formula shows that the covariance of these two features, let's say x and y features, and then divided by the standard multiplication of standard deviation of these two features. So the moreover this Pearson correlation is kind of the covariance, okay, and divided by standard deviation. So sorry. Okay, now in summary what we can say that the feature space and the target correlation is desired, and feature to feature correlation is not desired, which is known as a multi-collinearity. If two features are highly correlated, then either feature is redundant, so we need to remove either feature number 1 or a feature 2. A correlation in a feature space increases model complexity and reduces the model performance. Removing correlated features improves overall model performance and the training time. A different model shows a different performance over the correlated features. Okay, perfect. Now let's go ahead and start working with the example. So as you have already seen my previous video in which I taught a lesson feature selection with the filtering methods, and in which I had removed the constant, quasi-constant and duplicate features. And you can go ahead at my channel and watch that video. And before working on this lesson, you need to watch that video. Otherwise, you can download this file and you can get the link in your video description. Since I have already worked on this file and on the dataset, let me go ahead and show you. So initially in this lesson, which was you can say before this was a constant, quasi-constant, duplicate feature removal, in which I had shown from where you can download the data files, and then I had shown you how you can remove constant features, and then how you can remove quasi-constant features, and then how you can remove duplicate features. Okay, so after removing a duplicate features, we had training and the testing data set, which is known as xtrain unique and xtest unique. Okay, so these are the data set after removing constant, quasi-constants and duplicate features. Now in this lesson we are going to utilize these data sets, xtrain and xtest data set. Okay, these unique data set. So you can say this video is a kind of the part 2 in this the filtering method. So before working on this lesson, you need to see my previous lesson so that you can get this xtrain unique and xtest unique. Now let's go ahead and start working with the correlation. So what we are going to do, we are going to first calculate the Pearson correlation coefficients for training and the testing data set, and then we will select only those features which have a correlation of less than 0.85. okay, perfect. So let's go ahead, first calculate the correlation matrix by using CoreMat, and that we are going to select from xtrain unique by using core methods in Python. Once you have that, now let's go ahead and see this correlation matrix, visualize this into a heat map using a Seaborn library. Okay, so here we have a plt.figure, and then we have a fixed size is equal to 12 by 8, and apart from that, here we are going to utilize sns.heatmap, and in that we are going to see a core mat. Now you see here sns.heatmap. Now if you see with the, and match with the color bar, and there you see a white color, mostly white or very black color. So these white and black color says that the features are very highly correlated. Okay, so whatever features here and here intersects, that's mean these features are very high correlated. So these are the positive correlations, and these black lines are a negative correlation. So in this lesson, we are going to learn how we can remove these the very positive and the very negative correlated features. So the overall feature space should be reduced. Okay, so to calculate the correlation, we are going to write here a Python method, and there we can calculate the overall correlation. Okay, so our task is here to select all the correlated features which are correlated more than 85%, let's say from here. Okay, so which are correlated more than 85%, and from below this, so we are going to do absolute of these correlations so that it would be only the positive there, and then after that we are going to filter out those correlated features. Instead of the theory, let's go ahead and see with the example. So def get correlation, there we need to pass a data and threshold. Data means that it's the correlation matrix, and the threshold means the data means xtrain, the testing and the training data. So here we will pass the training data to reduce the chances of overfitting, and the threshold means for which we want to select the threshold means after which we want to discard the features. Okay, so here we will have core column, that's the correlated column. We are going to create here a set, since there could be a same features, occurrence of a same feature multiple times. So if we create a set, then a same feature would not repeat multiple time. And then here we have a core mat is equal to data.core, that's mean the correlation here, correlation matrix. And then for I in range length of core mat dot columns. So it is going to iterate over all the features from feature number 0 to total feature number 243. That's when there are total 244 features are in this data set. Okay, perfect. Now after this, once we get this, so what we need to also do, we need to go ahead feature to feature. That's when feature 0 to feature 1, feature and feature 2, feature 3, feature 4, and then from feature 1 to feature 0, feature 1 to feature 2. And we should not go a feature 1 to feature 1, feature 2 to feature 2. Since if we compare a same features together, then that's when the correlation will be the 1. And in that case, we will get almost at least one time correlation 1. Okay, along with the diagonal. So we will not consider the correlation between the same features. So for that, we need to do here for j, okay, j in for j in range I. And after this, we need to do if abs, that's mean the absolute value of correlation. Then we need to do core mat and then iloc. Okay, so here we have a core mat and the iloc means the location. So we are gonna get here location I and the j. In this case, if I is let's say 1, then j will be only 0. That's mean here we will get 1 and the 0. If I is let's say the 2, then the j will be the 0 and the 1. In that case, we will get I is equal to the 2, 2, 0 and the 2, 1. And similarly, we will start from the I is equal to the 0, I equal to the especially 1 in fact, and j would be the 0. So the 1, 0, 1, 2, 1, 3 kind of till 1 and 243. And then we will start from, since we have already compared 0 and the 1, now we don't need to compare the 1 and the 0. So in the same way, it will, the keep going. So here, if abs core mat this and that is the greater than threshold, that means here it is greater than the threshold. Now we need to get the column name. Okay, so here we can say the call name. The call name is equal to core mat. Okay, so core mat and then columns at ith location. And then here we have core call, that is the correlated column, and now we are going to add that into correlated column set. Once it is done, then we are going to return this correlated list, the set of the correlated column. Okay, so this is the method. This is a method or a function from where we will be doing, we will be filtering out the correlated features. Now let's go ahead and call this. So with this, we can set the core features. The correlated features is equal to get correlation, and there we are gonna pass here x and then train the unique. Okay, so unique, and then here we have 0. Let's say the 85. So this is the now we will be getting all the correlated features which are correlated with more than 0.85 correlation. Either it could be the positive or the negative. So these are the set of the features like 5, 7, 9, 11, 12, 14, 15, etc. So I think that is somewhere here which are pretty much the white here. And if you go ahead and see here, it's around 12 to 18. Those are the pretty much also the white. You see here 12 with these feature space. So these are the pretty much the correlated with each other. Now we have got the list of the features which are correlated. Now our task is to remove these correlated features and then test the train and the test our model. Okay, perfect. Now let's go ahead and get the overall length of these correlated features. So we can get with the length and then the core features. So it says that there are total 124 features which are highly correlated. Okay, perfect. Now let's go ahead, get uncorrelated features. Let's go ahead, filter out these 124 features from our training and the testing data set. So here we have X train uncore, let's say, is equal to X underscore the train unique. Okay, X underscore unique. Now let's go ahead and drop the correlated features. Their labels is equal to core features along with the axis is equal to 1. And after that we have here X test underscore uncore, that's mean uncorrelated features. Then we have here X test underscore the unique dot drop, and after this we have labels is equal to core features along with axis is equal to 1. Okay, so here we have a training and the testing data set. Now let's go ahead and get X train uncore shape, that is this one, and the X test uncore dot shape. So here now you see we have got 103 just, okay, 103 features which don't have the correlated features more than 0.85, which don't have any constant features, which don't have any quasi-constant features, and which don't have any duplicate features. So in this way we have removed all the constant, quasi-constants and duplicate features, as well as uncorrelated features which have a correlations always less than 0.85. Okay, perfect. Now let's go ahead and get a training and the testing time for this one. So for that we need to do here the time and then run random forest algorithms, and there we are going to pass here X train uncore and then X underscore test uncore, and then we have here Y train, and similarly we have here Y test. Let's go ahead and see this. So in this now again we have got the same accuracy 95.87%, but if you see here the training time is 912 millisecond only, and if you remember in my previous video this training time was more than 1 second. Now let's go ahead and run this on original dataset and see how much training time it takes. Okay, so here we have time and then we have run a random forest, and after this we have the X train, and then here we have X test, and then here we have Y train, and then here we have Y test. Let's go ahead and see how much the training and the testing time it takes. It says that it took 1.53 seconds of total training time. Okay, so original data took this time, and here the after correlation data, after removing all the constant, quasi-constants, duplicates and the correlated data, we have got 912 milliseconds only. Now let's go ahead and see overall gain, how much gain we have here. So that means 1.53 minus 0.912 and then multiplied by 100 divided by 1.53. So this says that here around 40% of gain into our training time, and we have here a very small amount of accuracy gain as well. So this this lesson and till now, this we can make an statement that whether our accuracy doesn't improve pretty much or with the very high, but the training time has reduced the y factor. So it's around 40% now the training time has been reduced. So in case, let's say if you are dealing a very big data set, then in that case this is very good and fantastic, where you can remove uncorrelated features and unnecessarily features, and you can reduce overall dimensions of your data, and you can handle a curse of dimensionality. So in this lesson, what we did, we actually we did kind of the brute force here. That's mean we had removed all the correlated features here, but this is not always recommended. There could be cases where some group of features are correlated with each others only. That's mean we only need to remove certain features, and we can keep some features by testing the features importance. Okay, for example, let's say here in out of 124 features, there could be kind of the 10 groups where they are correlated. That's mean we can divide all the correlated features in kind of the groups, and then finally we can select a single feature in each of those groups after performing feature importance. So here now we are going to do a feature importance and the grouping of these correlated features. Okay, so here I can say that feature grouping and feature importance. Okay, perfect. So here we have already cormat. Okay, that is the correlation matrix. So in this way, what we are going to do, we are going to first create a stack. The stack means, for let's say for this 0th row, we will put all the for the 0th row we will put all these the column, and then for first row we will again put all these columns, and for second row. That's mean it's kind of the vertical stacking. I'll show you how we can do this vertical stacking. So let's go ahead show you how we can do this vertical stacking. Here in the core data, we are going to do here, let's say the cormat first. That's the correlation matrix, and then absolute ABS, so that it could be in between 0 and the 1, and then we are going to do here a stack. So in this way, what it is going to do, it is going to do a stacking of the features. That's mean here the first 0, it took the 0th row, okay, this 0th row, and then against the 0th it put this whole column, and then again for one row, for one, then it put all these columns. So this goes the same way. Okay, you see here, this goes in the same way. Okay, so in this way we can get comparison of the correlations from, let's say, the 244 to 0 to 244, and similarly for all other columns and the rows. So this is how we do the stacking into a pandas data frame. If you don't know how to do these things, you can go ahead and watch at my channels about this pandas lessons in very details. There I have taught about the pandas crash course that is around 1 hour long. Okay, now let's go ahead and do a sorting into ascending order for all these values. Okay, so here we get core data is equal to core data dot sort values. Okay, so core data dot sort values, and there we are going to do the ascending false, that's meaning to a descending order. And now let's go ahead and see this core data. Now in this way you will see this is kind of into a descending order. So highest values here comes first. Now you see here the 29 is correlated with 58, 58 is correlated with 29, and 134 is correlated with 158. So it goes on. But now after some points, you see here we are getting a correlation between the same between the same feature space. Okay, so what we need to do, we should not filter out these correlated, otherwise we will get at least one correlation for each features. So we will also remove these one, I mean we will keep these, and if we see if 159 is correlated other than the same features, okay, 159. So now what we are going to do, we are going to do a grouping. Okay, so here let's say if feature space 29, so what are the other features for which this feature 29 is correlated? Okay, so let's go ahead and do this, and we can do that by selecting the features which is in between 0.85 and 1. Okay, so let's go ahead and get that. Core data is equal to core data, and there the core data where 0.85, and similarly the core data is equal to the core data where the core data is less than 1. So it is the same where I had mentioned that we should be also doing a focus where we should not filter out if the correlation is exactly 1 for the same feature, like 160 160 161 161 kind of this. Okay, perfect. Now let's go ahead and see this core data. Now you see it says that 143 is correlated with 135, 135 is correlated with 143. So this is how it is working. So although this is showing that its correlation is 1, but believe me, this is not exactly 1. So this is the limitation of the digital system. That's why it is showing that it is 1, but it is somehow nearby 1. Since we have already removed all the correlated features which is correlated by 1. And other than the same features, there is no features which is correlated. Okay, why? If the correlation is equal to the exactly 1 other than for a same feature, that means those features are duplicate, and we have already removed those duplicate features. Now let's go ahead and perform the grouping. Okay, and so for that we need to convert this into a pandas data frame. Okay, so here we have a core data is equal to pd dot data frame, and then here we have a core data. Let's go ahead and do a reset of indexing, and once we do a reset index, okay, so here a drop is equal to the true. Now let's go ahead and set here a core data. Sorry, we should not set drop is equal to the true here. The core data dot columns is equal to here we have features 1 and the correlated features 2, and then here we have the core value. And now let's go ahead and visualize this core data. So in this you will see here the feature 1, feature 2 and the core value. Okay, perfect. Now this is nice visualization. Now here we are going to do our the grouping of these correlated features. So for that, what we are going to do here, we are going to create a list for a grouped feature. So the grouped feature list, and after that we are going to do here the correlated group list. Okay, so the first we are going to get a group of features, and then we are going to create a list of those group features, and then we will find feature importance for each group, and then we will select only one feature from each group and we will discard other features. So let's go ahead and start with a for loop there. So here we have a for feature in the core data dot features 1, then dot unique, and after this, if features are not in grouped feature list, okay, that's mean it is going to see if this feature is not present into a grouped feature list, then we should consider this feature, otherwise the grouping has been already done and we don't need to do a grouping. Okay, so let's go ahead and find all the correlated features in a group. Then here we get a correlated block is equal to the core data, and there we are going to get here core data dot features 1 is equal to feature. Okay, so let's say if these features 1 is equal to exactly this feature 1, then we should put it into a correlated block. Okay, perfect. Now what we are going to do, I mean this is the value actually. Okay, so if that is equal to the feature, now let's go ahead and get here the G or UPD grouped feature list is equal to grouped feature list the plus a list of correlated the block dot features 2. Okay, so here we have got features 2 dot unique. So in this way what we are going to do, we are going to get if the two features are same, that's when they are into a same correlated group, and then we are going to get the feature 2 of that correlated block. That means it is saying that, let's say if we have here a feature 143, so it is going to get all the features in this 143, and then it is going to look all the feature set against this 143. That's mean those feature set will fall into a same group. Since if this feature 143 is correlated with 135, then that's mean any features correlated with 135 will be also correlated with highly correlated with 143. So here in this way we are going to get the same the correlation which is correlated with 143 and similar kind of the features. And then here we have a feature. Okay, perfect. And then here we have here correlated group list dot append the correlated block. So in this way what we do, we have created a correlation, we have created a group, a list of grouped features. So first here we have got the correlated block. Okay, so once we have got a correlated the groups, then after that we have put it into a list. So let's go ahead and run this method. This says that we don't have a features 1. So let's go ahead and see what is this. This says that into a capital features 1. Otherwise what we can do, we can create here a small f. This should be a small f. Just run this. Okay, we have already did here a data frame, so there I have just made a mistake, so I think I should run it from here again. Let me run it from the initial. From here we have a core mat, this one, and here. Perfect. And after this let's go ahead and run this. So here we have got this 120. Now let's go ahead and print total correlated groups. Okay, so that is the correlated group list. So let's go ahead and print the length of this correlated group list. So out of those total I think 114 the correlated features it was. Let me see how many features were correlated. It's somewhere we had, I think it was 114. something like that. So there are total the 56 group existed in out of those the correlated features. Now in these 56 groups we are going to get a single feature based on the feature importance of the total features. So now let's go ahead and get a total features. As we know, the total features are initially the total features were, how many features were there? Total 370 features. Okay, so but we also had there, if you see here in Xtrain Uncore, so in uncorrelated we had total 103 features. Okay, since we had removed all the features, the correlated features, so that's why we had only 103. But here we are going to put these 56 more features, so that from each group. Okay, now let's go ahead and select do a feature importance based on a tree based classifiers. Okay, so here we are going to do a feature importance based on tree based classifiers. Okay, so the feature importance, the tree based classifiers like decision tree or random forest classifiers have a feature importance, and they calculate the importance of each features in classifications for output. So we are going to use the same techniques to identify best performing features in each group, in each correlated group, and then we will select the best performing features out of those correlated group. And for that we can do here important features. Okay, for group in the correlated in correlated group list. But before that I would like to show you some groups. If you want to see the group features, then how would you see those groups? So that we can get for group in correlated group lists, and let's go ahead and print these group, then I'll show you. This says that, see here, for a first group it has a feature 143 and 135, and for second group it has a feature 136 and it is correlated with 128 and 169. And similarly you see here for feature 52 we have here these correlated groups like a feature 23, 24, 53, 21 and 183. That's mean if we select only one features out of these groups based on a feature importance, then we can get a maximally performing the features instead of just discarding all the correlated features. That's mean, let's say if we have only the two features and those two features are correlated with each other, then instead of discarding those two features, we should see which feature is performing more, since only we need to discard on single features so that we can remove the the correlation. So in the same way we are going to work here. Okay, perfect. Now let's go ahead, get with the features is equal to the list, and then here we have a group, and then we have features 1 dot unique, right? So if feature 1 have multiple same features, then it will get just single features, and then list group dot the features 2, then dot unique. So you see here in the feature 1 it will get first single feature, just let's say the 33, but for features 2 it will also get unique features, although in this case everything could be a unique. Okay, so in this way we will work here, we will create these groupings. Okay, perfect. Now let's go ahead and get here the features is equal to the list group features 1 and feature 2 uniqueness. So we have got total the features, so these total features, And once we have got total number of features for particular group or a particular group, then we are going to calculate importance for each of these features. That we are going to calculate here the random forest classifiers. And then we have here n estimators, they are 100. And then we have here a random state, let's say for 0. Then here we have rf.fit, then here we have xtrain unique, then we have here features, our features, and then here we are also passing here y train. Okay, perfect. Here then we have importance is equal to pd dot concat, concat, and there we are going to do a pandas series first for features, and after that we are going to do a pandas series for a feature importance. That's the rf dot features rf dot feature importances, and that we are going to do along with axis 1. Okay, so once we are done with this one, then importance dot column names, which we are going to do here, that we are going to write here features and along with their importance. And then we are going to do here importance dot sort values. Okay, so I'm doing operations on a pandas data frame there. Sort values by, that's mean on which column we want to do the sorting. So we want to do a sorting on importance column, and here we want to set ascending is equal to false, and we also need to say here in place is equal to, let's say, a true. Okay, after that we are gonna get a first important feature. Since it is sorted into the descending order, that's mean highest important feature would be at location 0, that we can get with I log 0. Now after this, for each group we need to put into a list that is important features, and then here append it. Then with the fit we can append it. Now let me tell you how it is working. So first we created an empty list for important features, and then we are going with group by group. In each group we are calculating here most important features, which is located at a 0, because I have sorted this into a descending order. And once we get most important features for each group, then we make here a list of these most important features for each group. And now we have got the features list for each group that we can print by just calling this important features. Now you see here, so these important features 128, 62, 47, etc, etc. So now let's go ahead for each group. I have got that. Now let's go ahead and create a pandas data frame. So here we have important features is equal to the pandas data frame, important features. Now let's go ahead and do a reset of index. So we can do important features dot reset index, and there we can set here in place is equal to the true, and here drop is equal to true. Okay, perfect. Now let's go ahead and see these important features. Now you see here, these are the features and their importance. So these are the total features for each group, and there were total 56 group, and we can see here They are total 0 to 55. That's when there are 56. So we have selected a single features from each group. Now let's go ahead and create a total the total features which we need to drop. Okay, so we can say here the features to consider is equal to set of all these important features from where we have got features, and then we need to find out the features which we want to discard. Okay, so those features are set, and the total correlated features which is present into a core features. If you see in my previous video, there we have got the total correlated features. Okay, so before this video, since this is same working file, so if you download this file, then it will work there. You see, I think in this video itself I had created that core feature somewhere, right? So that is here, right? So it has here the core features. So once we have got these core features, so out of all the correlated features, we need to filter out these features as well, and then remove all the remaining features. Okay, so the set of the core features minus set of the features to consider. Now we have got the features which we need to discard. Okay, perfect. Now let's go ahead and do a features to discard. Create a list for this one. There we have a features to discard. Perfect. So we have got a features to discard. Now let's go ahead and get a new data set after discarding the correlated features and keeping at least one feature from each group. So here we have xtrain underscore xtrain grouped underscore uncore x underscore train underscore unique. Okay, and then here we have a drop, and then here we have labels is equal to features to discard, and here axis is equal to 1, and then here we have xtrain grouped uncore. Okay, xtrain grouped uncore dot shape. Now there you see here we have got total 140 features, right? So earlier when we had discarded all the correlated features, we had just 103 features, but here now after keeping the features from each group, a single features, highest performing features from each group, now we have total 140 features. Now let's go ahead and create our x test grouped uncore feature set as well, so that we get x underscore test and then grouped uncore is equal to x underscore test underscore unique, then dot drop, and there we have labels which we want to features to discard. Okay, along with axis is equal to 1. Now let's go ahead and see this grouped features uncore, the shape of this. Now you see this also has 140 the feature groups. Okay, so here we have got our training and the testing data set. Now let's go ahead and run our algorithms on this training, newly created training and the testing data set, and record overall training and testing time. So here we have run underscore random forest, and then here we have grouped uncore. Here then we have x underscore the test grouped encore, then here we have y train, and then here we have y test. Sorry, I think we should put here time. Now let's go ahead and see. So we have got total 1.01 second of the training time, and overall accuracy is 95.77%. Now let's go ahead and create here our, and let's go ahead and run on the original data set. So on the original data set, we have X train, and then here we have X test, and then here we have Y train, and then here we have Y test. Let's go ahead and run this. So on the original data set, you see we have got 1.48 seconds for a training, but for on these uncorrelated data set, after keeping the features from each group, we have 1.01 second. So, and the accuracy you see on the original data set, it is kind of a little larger than after keeping these the group of uncorrelated features. But if you remember, if we discard all the correlated features, then we had a better accuracy. Okay, and we can do that by running the time and then the random forest, and X train, we have, I think this one, encore, and X underscore test, and then encore, then we have Y train, and then here we have Y test. So now you see here, if we discard all the correlated features which have correlation coefficients more than 0.85, then the training time is just 0.89 second. But if we keep a single feature from each group, then the training time is 1.01 second. But if we train our model on original data set, then we have around 1.5 seconds of the training time. So in any of these two cases, you can see here very clearly that after selecting a particular features, the training time has been reduced. So basically we can make here a statement that if you are handling a very large data set, then in that case, the feature selections would be really very important to reduce the total dimensionality and the complexity of your features. And once it is done, then you can simply train and test your model by giving the particular constraints, performance constraints, etc. So this is all about in this lesson. Thank you so much for watching this video. Please don't forget to like and subscribe this channel. If you have any doubts, please comment below. We will discuss about this. And if you want any further videos on any other topics, please comment below. Bye bye. Have a nice day.